Hi everyone, welcome to a new episode of Ask the Trainer. Today we are going to talk a little bit about MoGraph Effectors. Did I say we? Yes, I did. I've got a few nice and cool people here on Ask the Trainer as well. So Thanasis is going to help me explaining all of the cool stuff that you can do with effectors. But we also have Darren on here, we have Sasi on here, and Ellie, and they are going to help out with questions in the chat. And now I forgot who of you is going to be on screen as well, but they are there. They are going to hear you or read whatever question you write into the chat. All right. So I'm going to do the housekeeping first. And as always, you might know that already. If you go to the Maxon website and then under news and events, you can get to this site where we have all of the upcoming events and webinars hosted that we are doing. So we've got like VFX and Chill tomorrow. We've got demystifying post-production with Raise Your Redshift game as this month's topic. We've got an intro to rigging hands-on with Maxon course running at the moment and Maxon Color, as well as a few other things. And if you missed one of our sessions, you can go to the Maxon Training Team YouTube channel, and here we upload almost everything that we do live, and you can rewatch it here or in case of VFX and Chill on the Red Giant YouTube channel. So we are going to talk about effectors, and the reason for that is because effectors are part of our certification topics list. And our concept for this session and also like a few other sessions, Ask the Trainer sessions, is that we are going to pick a topic out of this topics list, and then we're going to discuss it a little bit more in depth. So where can you find that topics list? If you go to maxon.net/certification, you can find that under Learn and then Certification. Then you can see that there is the C4D Basics Comprehensive Test, and in here, there is a link to the certification topics list. And here you can find all of the stuff that we might ask in the certification test. And today we are going to talk about MoGraph and MoGraph Effectors in particular. So the last thing I want to mention already is that we want to thank you for attending, and we're going to do that by giving away free t-shirts. So there is a coupon code that you can use if you go to that website that my dear colleagues are going to share in the chat. And if you go to that website using the coupon code, you can order one t-shirt for free, and you will only have to pay for the shipping. All right, that's enough of the housekeeping. We want to get to the exciting stuff inside of Cinema 4D. So let me hand over to Mr. Noseman himself. And yeah, Thanasis, what do you have?
Well, good morning, everyone. Today we're going to talk about effectors, and just to make sure technically, I am sharing my screen. Is that the case?
Indeed.
Oh, thank you very much.
Yes.
So I am going to begin by giving you a very quick, very quick overview of pretty much all the effectors, and just provide you with some information, because during the test you will be required to understand the fundamental principles behind what effectors do. In some cases, for certain effectors, we are not going to go into the weeds with the test, but having an understanding of how effectors work actually will allow you to do stuff much easier and make your setups faster and become more efficient. So very quickly, what I'm going to do, I'm going to go to the MoGraph menu and pull up the menu that has all the effectors, and I'm going to use the plane effector. just to give an overview of the parameters. So effector tab, parameter tab, deformer tab, and this is something that Jonas is going to talk about, and the fields. I'm not going to touch on these two for now. So let's begin over here. The effector is a mechanism by which we can modify a cloner's anything that is a cloning device or a matrix or anything like that. In the transform tab, as we talked about last time, we have all these parameters. We have the indices, we have the matrix here, these 9 numbers, the color, the weight, time, UVs, and various other things inside that mode data, the MoGraph data that exists. And the effectors, through the parameters tab, allow us to modify those aspects, and they do them in different ways. The plane effectors are more straightforward, and when we do the I would say the next session on MoGraph, we are going to introduce fields in the mix, and I'm going to give you an explanation of how the whole system works, comparing it to After Effects, because that's something that most people understand, and masks and all that. Anyway, back to effectors. In the parameter, we have, besides the actual parameters, the position, the rotation, and the scaling, and these are pretty straightforward what they do. And the colors, which can be either off, not affecting color, the effector color itself, a custom color, or the fields color, the colors that come through the fields through that little list here with the little field. And then we have the use alpha strength, which is something I am going to make a tutorial about. It has no place in this particular presentation. It has to do with masking the values. And then all these things like the weight transform, the U and V transforms are relating to the UVW, the modify clone for sorting and blending, the time offset for keyframed objects, and the visibility, which is just turning on and off various things. And the plane effector has the full range of these things. Now, just the most mysterious of all are these little buttons here. And the problem is that they don't show anything different depending on the situation. I'll give you the 2-minute overview somewhere around here in the transform space. So I'm not going to do a full explanation. I've got a plane effector with some animation playing through a vibrate expression, vibrate tag. I have a cloner that is cloning these little axes so you can see the actual directions. And the cloner itself is set to linear. It's creating 10 clones at 174 centimeters. And you can see that now we are using only the H rotation and the transform space node. Node is actually our cloner. Try and ignore this, the plane effector. Let me turn it off because, oh, I'm selecting it, so it's always going to be on. So as you can see, the clones are just following the rotation of the cloner. As the cloner is rotating, they're rotating. Now, if I go and select effector, then look at them. They are taking their parent's rotation, but added to that, they're getting the plane effects rotation. So effector allows you to do some of the modifications, some of these parameters, apply them in the space that the effector is lying. So if it's rotating, then the axes are going to rotate. And as far as the object is concerned, this is a bit more hard to understand, but basically I will compare this with the node, which is straightforward hierarchy. The object takes into account both the rotation we're applying with MoGraph. That's why you see this extra rotation happening on the z-axis. So it does allow you to place things with different configurations, but this particular knowledge for these 3 things is not required for the test, but we will expand our tutorials on explaining how you can use these. So let me stop this animation and start talking about the effectors in the list, in the order that they appear. So the delay effector is very, very simple, and that is to modify. I've created, if I turn off the delay, I've created this very quick animation where it goes within a frame to one state or another just by changing the value of the Y. The delay effector allows you to apply a delay, and you can see in the parameters, it only affects position, rotation, and scale. It doesn't affect all the other possible parameters like colors and alphas and weight transforms and so forth. So always make sure you hit the parameter tab to see what's going to be affected. And basically, the delay effector allows us over here to set 3 modes. Now, the even is all the values are going to blend. The stronger this is, the more smooth the action is going to be. But the even is just a linear transformation. Both are blending. Even and blend are some sort of smoothing operation. But the blend is just ease in, ease out. It just starts slow, goes faster, and then slows down. And the final one is spring, where you apply whatever motion you apply, and depending on the how the spring is set, if it's very soft or if it's less soft, it allows you to do all sorts of animations, and then you apply the delay effector and just smooth out the animation so it doesn't have jittering and stuff like that. So that's the delay. Let's go to the formula effector, and this is something that Jonas is going to show you a few more things. And I have just a text written here of the formula I'm going to apply. This has 2 clones, a brick and a cylinder, and it's set to sort mode. Sort mode, as we already know, allows you to choose which of the clones you're going to make visible. You're going to choose from the hierarchy just by using an effector. And over here, I've added this, and this is a logical expression. If you like this kind of geeky stuff, then it's fantastic. This says that if the U parameter of the clone, and the U, as I said, relates to where each clone lies in the bounding box of any cloner. So if the U is larger than 0.99, we know that 1 is the maximum. I just put it 0.99 to avoid any mathematical errors. Or these 2 vertical bars is or U is smaller than 0.001. And what this does, it returns a truth statement, a result, a Boolean. So if the U of each and every one of these clones is bigger than this value, or smaller than this, or, and this is one statement in parentheses, you have to put them in parentheses if you want to compare more than 2, or the W is larger than 0.99, or the W is smaller than 0.11, then the value for those clones, as far as which one the sort is choosing, is 1. And this way you can take structures like this. This is how you would make a procedural house, by defining the edge cases, where the walls are going to be, where the ceiling is going to be. The ceiling is going to be not U, not V, because these are the X and Z, but the Y. So if you want to create a roof to be made out of different types of bricks, you will put that type of brick as a clone, and you would say that if V is larger because it goes upwards and stuff like that. So the formula can do many things if you're willing to go in the variables and then read the documentation and use these variables to control things. But it's extremely powerful once you get around this weird sort of the way you're going to write things. There are quite a few examples in the help documentation. Good. Inheritance. Inheritance is one of the most powerful effectors, and basically you can transfer through the parameters position, scale, and rotation, nothing else, and you transfer it from another object. So instead of as an effector, the effectors always compare things to the plane effector. The plane effector determines the values of whatever is going to happen, but the inheritance effector doesn't determine them. It reads them from somewhere. So currently it's reading the matrix sphere. So this is just a matrix in object mode and a sphere in here. And I've cloned 100 little matrices here. And what I'm telling this dude here, the cloner cells, through the inheritance effector is to, as we're applying, so if you go to the inheritance effector, I've applied the strength. The stronger this value, so this is value 1, this is value 0. At value 0, it's not going to inherit anything. But at value 100, it's going to read one by one all the positions, scales, and rotations from the target object, and providing the morph motion object is on, it will allow you to animate as well. And I've added some dynamics and an obstacle in the middle just for some fun. And watch this. They're going from one place to the other. And the great thing about the inheritance effector is that the final state is deterministic. because these are set by index, we know that 100 of these spheres are going to align to 100 of these matrices. So we can create more than one state. We can create 3 or 4 different states of where we want these things to go, and use the strength animation to move these from one to the other, to the other, to the other. And they will always end up in the positions we've designated. For example, if I tell this very quickly, matrix effector, where's my matrix? Matrix sphere to be linear, and add a bunch of these, now they're going to move to this position. So you imagine this now, you can place them very, very, very accurately. And because we have a, let's say 10, we're going to get 10 spheres for each and every one of the matrices, because we have 100 spheres. So as you can see, this is extremely powerful to create deterministic animations and put your clones exactly where you want them to be. So let's go further down. Push apart, that's Jonas is going to show us some fantastic examples. Let's go to the Python. Very quickly, I talked about it last time. I'm going to spend 30 seconds. There are 2 main modes. The parameter control, I'm going to open this up. The parameter control just returns the strength. That's what it returns based on whatever you want to do. And the full control, that's why the default code changes. The full control allows you to control every single one of the parameters that exist within the mode data. That's why you see get mode data and all that kind of stuff. If you're in Python, check it out, because you can do some fantastic things with that. Next, random. So very quickly, the random randomizes these parameters. There you go. And it's pretty much all the parameters. Now, the random has certain interesting things. The default minimum and maximum value is not 0 to 100 like everything else. If I add a plane effector here, you'll see that the default is 0 to 100. But the random has minus 100 to 100. That means that it will have a balance between negative random values and positive random values. Now, what do I have here? I have this going up and going down, and going up and going down. These parameters here are extremely powerful, because this is just randomization. This is a different type of randomization. Here we have a certain noise, so you can control the type of randomization, a turbulence. And then we have sorted, and there's a great example, as far as I know, Jonas is going to show you, but if you right-click and go to help and look at the sorted example with some playing cards, 52 playing cards, it just allows you to assign a unique random value to each clone. So you can create random playing cards without having double textures. So it's very quick to do that. And that's something you're going to be tested on in the test. Now,
well, I thought you're going to show it.
I could.
Okay.
Yeah. If we have enough time, because it's taking slightly longer than I wanted. So as far as the random effector, the synchronization here, so let me go back to random. The synchronization, what it does, it applies the equal randomization in all the parameters. So what will happen is that the ones that move higher are going to rotate more, whereas without the synchronized, it will just put random values for the height and random values for the rotation and so forth. So if you want to synchronize the positions, the rotations, and the scales to receive the same randomness, you put on randomization. And again, the example would be the higher a cube goes, the faster, the more it will rotate. And you will see this, that the ones that stay closer to the center line rotate less, and the ones that go higher, and I don't have synchronized on, that's why it's not happening. There you go. So the ones that go higher spin more. The ones that stay closer to the horizon, to the floor, spin less. So that's how you synchronize them. And finally, this parameter here, the indexed value, it just allows you, when you're using noise and turbulence, which by default use sort of black and white noises, just like the textures, in order to avoid motion that goes diagonally. Because if you apply each and every one of these randomnesses, if you apply, let's say, 100 and 100 using a noise, what you will see is that they're going in a diagonal fashion, because as much as the X increases, the Y increases as well. If you go here and you do an index, it will actually randomize those numbers internally. So that's to avoid any visible artifacts, things moving sideways, which is an effect actually. If you wrongfully apply a random field on a plane effector, that's what you get. But that's for the next session. Okay, ReEffector. It's one of the most powerful effectors. And not many people use it. So the ReEffector was initially conceived as a sort of cancel effector. And what it allows you to do, it allows you to do two very basic things. You can take the effects of any previously applied effector and remove any of the parameters, right? And what I've done here, I have this example here. And what is the thing about this example is that I've used a Voronoi fracture using a circle in the source to control how my fragmentation is going to occur. And if I go here and put on the colors, you will see the fragments, right? But because the Voronoi fracture does not align the axes of each fragment based on the circle, because why wouldn't it? But at the same time, I want to be able to push them in a linear fashion, right? I've got dynamics here and all that, so it's sort of, and I've got some things going on. So what you would do is, first, I'm going to apply, as you can see from the effectors, I apply a target effector. And the target effector without the ReEffector basically just rotates these so that their axes are pointing to where the target effector is in the middle here. But I don't want the rotation. I just want the general orientation. So you go to the ReEffector, apply it on top of that, and you just tell the ReEffector, you know something, just ignore the positions or ignore the rotations. And this will actually allow you to move them now on their own axes where they're pointing. Anyway, the other thing you can do with the ReEffector is to group stuff. So you can apply in the matrix the ReEffector, and in the ReEffector in the effector tab, you apply the other effectors. So it works like a group effector, but it has the extremely powerful capability of you can go and remove some of the channels, some of the parameters. So instead of saying, make it 0 here, I can actually go and fine tune this and say, from the X position, I just want to apply, modify it slightly. So, and it can affect all the mode data. So it's an extremely powerful one. Quickly, shader effector. The shader effector just allows you to use either a shader directly here. You can either select a material. So I've applied a material to the shader, and this material is a noise, and this noise is controlling how the rotation of these things is going to be. I think I've got it animated. There you go. You can put gradients, you can put all sorts of other things. The other great thing about the shader effector is that if you want not to use from the applied material, the material dragged here, and just go custom shader and use any of the shaders here, or most of them, I won't say any, to create the effects. And that's great because you can you can use this with an animation, with a movie, and have these create sort of a rasterized effect by scaling these based on a black and white image. So you can do so many great things. Now, the spline effect, a very quick overview, it allows you basically to take any MoGraph object and distribute the clones over a spline. It has some complexity when it comes to the fall-off mode, and I think that's because this was designed before the fields came into play, and the fields, they sort of work, but it just causes a few confusing aspects. So just keep it in step, and you can align your text. It's perfect when you want to align 3D text on splines and stuff like that. And you can see from the parameter that you can align the positions, the rotations, and not the scales, because that doesn't make any sense at all. So quickly, step effector. The step effector is one of the simplest and most powerful of all effectors. It takes the first clone and the last clone and applies the maximum value to the last clone, the minimum value, which is pretty much 0 or whatever this is, right? That's the minimum value is always what we set here in the minimum. And it divides those values by the number of clones and applies them in a step manner, hence a step effector, which means that regardless of how many clones I have, it always applies the minimum to the first one, the maximum to the last one. You can create interesting stuff like that. And of course, you can go here and play with a little splines, control, press this, move it around, Don't double click, and you can create very interesting things as you build this. There you go. Fantastic. So step target effector. We talked about the target effector. It has a couple more options. It can target at the target object itself. So everything is pointing. The z-axis points there. It can look at the camera. So it's looking at me, looking at me, looking at me. You can create sprites this way. It's fantastic for sprites. You can look at the next node. So it's pointing at the axes. I've put the axes down here in the base. Every previous one is pointing at the axes of the next one, except for the last one that has no idea where it's going because it doesn't know that this is the first one. And very, very powerful one. It has some extra stuff like repel and so forth, which is a subject for other things, but you have no idea how much how much stuff you can do using all these things, especially if you start using it as a deformer. So where are we here? Time effector. This is one of the simplest ones. It applies these parameters based on the time per second. So these are going to move up 20 and rotate 45 in the H every second. That's how this is applied. So here's a time effector, and here's the effector, 0 to 1, and let's go and press play. So within 1 second, we have, go back, 45 degrees, and they've raised 20 from the ground, and it will continue going. So you can create a very simple continuous animation with this, and they just move on and on and on and on and on. Volume effector has nothing to do with volumes. It was conceived and created much before the volume system came into play, the VDBs. But what it allows you to do, if you go here, you will see the parameters we can change. You go to the volume and you apply any object. It's better if it's watertight, so it has no openings. And basically, it will apply these parameters to whatever clones happen to be inside that volume. That's it. Yes, please.
We got a question. How about Family Group is wondering, is there any way to avoid overlaps or collisions within the effectors?
Avoid overlaps and collisions within the effectors. The effectors have no idea what's going on with collisions. They just set values.
There are pretty much two ways. One is by using dynamics, and the other one is by using the push apart effector. That can help here.
Only with the radius, yeah. If you want proper collisions, you have to use dynamics, but it's not an effector's job to know where everything is. It just sets things. The push apart itself, it just iterated. Jonas is going to show you. So there are a couple of ways, but each way you need to approach it in a different manner. Yeah, you'll be happy with Jonas's explanation. Okay, and that concludes the list of general effectors. I'm going to let Jonas speak now and show us all the great stuff, and I'll be watching the chat. Thank you.
Cool. So I'm gonna share my screen now. So now you should see, some sort of wooden floor with a few dices on it, or die is the plural of it. However, that's not what we're going to talk about. We're going to talk about more effectors. And the first one that I want to show here is the formula effector. So there are a few things about the formula effector that are quite interesting to know. First of all, as Thanasis already showed, let me just create one of these. So here we go. That's the formula effector, and by default, it's doing some crazy stuff. Everything is a little bit small here. So let me go down here, and the thing is, in the formula, the default formula here is pretty intimidating. So as Thanasis also showed already, is that we have some parameters in here. Now let me set up a few variables. Let me set up a few parameters. I'm gonna undo the scale, so no scale. I just want to use position Y, like so. So now we can see pretty well that we have a sine animation in here. But what if we want to use some of these instead? So let me show you how it works. I'm gonna just type in ID it's going to use the object index. And as Thanasis might have showed you last time, if you go to a cloner and to the transform tab, there is an option where you can show the index of clones. So it's starting at 0 and then 1, 2, 3, 4, 5, and so on, depending on how many clones you have. And what the formula effector is basically doing, it's multiplying this, the result of this formula with whatever you have set up in here. And this is a pretty, it's a good example because you can see pretty well what's going on here. So we have position Y is 2 centimeters, and then we have this multiplied by the ID. That means 2 multiplied with 0 means 0. So this dice is exactly where it was before. Then we have 2 multiplied with 1, so this one is 2 centimeters up. 2 multiplied with 2, this one is 4 centimeters up. 6, 8, and so on. And yeah, that's pretty much a little bit like a step effector, but without the option to. I always point people to, if you right-click the formula parameter and then you go down to show help, you will find, of course, the help of the formula effector. But then this here is actually the most important sentence in this article. A list of possible formulas can be found here. So let's click that. And here you find all of the formulas that you can use. And there are something like, well, like a square function. So let's do this. Let me just, type in SQR and then maybe make that based on the ID. And suddenly we have this shape here, like a, is the English word for it a parabol? In German it is. However, so you can now divide this, let's say, by 10, and then you can see it much better. So here we go. The next thing I want to show here is that it is also possible to create like selections of or sequences of clones based on their index here. And that would be the modulo. So if I show help here again, there is a modulo function that I always show when I show the formula effector because it's one of the most powerful ones. So what is the modulo? If you divide any number by any other number, you can make it so that there is no remainder left, and then you can divide it in a way that you would have decimals. And the modulo doesn't like decimals, so it will just cut off everything that is behind the point, and instead will return the remainder value. So what does that mean? Let me show that to you. So let me type in mod for modulo, and then I open the parentheses and type in ID, then semicolon, and then 2. This means I divide the ID by 2, and this will return the remainder. So let's have a look at this. Here you can see that we now have sequences. So every second clone is going up by 1. Let me do this with 3. Then we have 1, 2, 3, 1, 2, 3. We have sequences here. Because if you divide 0 by 3, the result is 0, and the remainder is also 0. Then if you divide 1 by 3, you have still 0, but the remainder is 1. Then you divide 2 by 3, the result is still 0, but the remainder is 2. And then you divide 3 by 3, which is 1, but the remainder is 0. And in the remainders, you get those sequences, which is pretty cool. And the other thing that you can do in here is you can also say, okay, if this equals, if the remainder equals 0, then just modify that clone. And we can do that also with the fourth clone and so on. So we can affect every nth clone by using this formula. And if we want to go one further in this sequence, we just go up with this value here. So that's a pretty cool thing. The other thing that I really like about the formula effector is that you can use it to just pick one clone out of the whole MoGraph context here and reposition it and rotate it by using the effector position and rotation. So imagine like having like a fracturing setup where fragments are like flying towards the camera, and then there is this one fragment directly flying into the camera, and it doesn't look good. What you could do there is you could add a formula effector and just address this exact clone and control it by using the effector's position and rotation. And that's what I'm going to show you now. So what we need to do here is we need to pick out a clone. We have these IDs here, and I just showed you that you can also just type in here equals whatever. So let's just pick out the clone with the ID, let's say 5. So we type in ID equals 5. And now the only clone that the effector has an effect on is the clone with the ID 5. That's already cool. So we have a good start here. Right, now let me move the effector to another place, and let's also rotate it a little bit. And now I'm going to show you how you can use these transform mode and transform space parameters to set this up in a way that this is going to be directly or perfectly on that position of the effector. So first of all, we need to bring down the position here to 0 as well, the Y position, so it needs to be zeroed out. And then we set the transform mode to absolute because we want to absolutely inherit the matrix or the position of not the clone itself, but the effector. And now you can see that this dice just snapped into to the position of the effector. And you can also see that the rotation is not affected. If I switch it on, you can see that it's still not affected because you have to change at least one value here. So the easiest way to make this work perfectly is to type in 360 into one of those input fields, and then it will recognize the rotation here as well. And now you can select the formula field, formula effector, and just rotate it, move it around, and you can do that with any of these clones. So if you, for example, want to have clone 6 fully controllable instead of 5, then you just type in 6 here, and here we go. Now this is clone number 6. So that's what I wanted to show you when it comes to the formula effector. A good thing that you might also want to know is that everything that is in here can also be used in every single numeric input field. That's another topic, but just that you know, you can use all of those functions in every single numeric input field. As you might know, those numeric input fields are capable of calculating. Okay, so Thanasis, do you want to show something?
I've always got something to show. Or if I don't,
okay. I also have a few more things, like when it comes to the push apart effector or
yeah, go for the push apart, because that's a very interesting one. So I'd like you to exhaust that subject.
Okay, cool. So here I have a setup with some spheres cloned like in a honeycomb array. And now I want to use the push apart effector and the random effector to adjust those sizes of the spheres, and also to make sure that they won't intersect. So let me first create a random effector. Most of the time, a cool effect can be achieved by a clever combination of these effectors. So let me start with a random effector. This will just make everything random. And the next thing we can do here is we go to the parameter tab, and I don't want to, well, I want more randomness here in X direction, less randomness here. Let me go to 0 so that we have randomness in like one plane. And now you can see that they are intersecting like crazy. And as we mentioned earlier, there are two ways of avoiding those intersections. The one that really works by having like a collision detection in it is by applying, if you apply a dynamic simulation, like a rigid body tag, for example. The other way, which is a little bit more fakey, but works especially with spheres, is if you use a push-apart effector. And everything you need to understand here is that you should use the radius in here that you have in the sphere, also here in the radius of the push-apart. And this will push everything apart. The great thing about that is that even if the random effector comes first, then if we also adjust the size here or randomize the size, let's go with the uniform scale and let's do 0.5 here. You can see that it still works. So that's a very cool thing. And the other thing that is quite cool that I like here is that if you don't use the scale, let's just not use the scale here. And instead, let me go to Effector in the random effector and just use noise. So we have some animation in here. We're gonna take indexed to have some, separate directions on a per clone basis. And now you can see what this is doing. Like we have small movement. We can make this a little bit slower, and maybe we can accelerate or not accelerate, but make the strength a little bit more. Let's go with 200% here, or maybe 300. And now you can see that we can create those types of animation. Like this is a little bit too fast, but too much. Let's go with 200. But another thing you could do here, if you still have intersections, or if it's too snappy, you can add a delay effector to smooth those animations, and that would make the whole thing a little bit smoother. So sometimes there are cases where you might type in the correct radius in here, but stuff is still intersecting, and the more iterations you use here, the more accurate the result will be. Like iterations like until 100, the number of 100 are pretty smooth. If you go higher, it will slow down the setup a little bit, depending on how high you go. So yeah, that's a great thing that you can do with push apart. And the other thing that you can do with push apart that I want to show you now is you can use any effector also as a deformer. And many people don't know that, but it is possible and it is quite powerful. Let me give you a little example. I'm just going to create a new scene here, throw in a platonic, and now I'm going to add a random effector, and I'm just going to make it a child of the platonic, because as you might know, deformers have to be children of the objects they need to deform. And now you have a deformer tab here, and you can use that deformer tab to set the deformation mode from off to, let's say, point. Then we would randomize points, and this way we can create stuff like that. And let's, for example, go with the random mode noise, and then we have some noisy randomness that is animated without any keyframe. And so this can be used in quite a variety of ways. The other thing that is that can be quite cool, let me double check. No, that's not the scene. Effectors as deformers. Here we go. So what you can also do with that is, like here we have a cloner that has some cubes in there. Let's make this cloner editable so that we have like a null and multiple cubes beneath that. So what you can do here, for example, is you can, let me go to the plane effector. The plane effector is just doing the same thing to all clones usually, but I'm going to use it as a deformer here. So first of all, let me set it up. Yeah, I think that's fine here. And I'm going to make it a child of the cloner here. This way, it will affect everything as soon as I make it a deformer. And in this case, I don't want to deform points, but full objects. And you can see that they are going up. Now, we could add a fall off. We're gonna cover fields next time to some more extent, but I'm just gonna show you a little example. We're gonna add a linear field here to create like a linear fall off, like so. And I'm just gonna adjust the remapping a bit. We're gonna go through that next week. So I'm gonna set the contour mode to curve and then create more like this bell shape. And now, although these cubes are not part of the MoGraph context anymore, we can still move them from like one place to the other, and it will perfectly react to that thing, to that deformer or effector, because the effector is set up in a way that it's behaving like a deformer. Now, if I set this plane effector deformer mode back to point, you can see that something else is happening. So by default, all of the points are deformed in Z direction. So Z direction is normal direction. And that means that right now everything like will be moved in Y direction. That's why it's not looking so well. But let me go to the plane effector and instead adjust the transform space to effector, and then we have something like this. So now if I move those clones through that field, you can see that we have something like a bridge or so. Okay. Back to object, and it works like that. Cool. So yeah, that's everything I wanted to show now. Let's jump back to Thanasis. You have something else to show, right?
I always have things to say.
That's cool. And then I have one more, but let's first do your stuff, and then I have one more thing that is related to animation, animated clones.
Excellent. Let me share my screen.
Yeah.
It's trying, and I think it succeeded. I'm typing one thing. Oh, actually, I'm going to explain this. One of the questions was UVW has nothing to do from Demisart. UVW has nothing to do with texture coordinates. I thought I had to involve the PX, PY, and PZ variables. Again, I want to repeat this. When we are talking about the MoGraph UVW coordinates, it's where an object lies within the bounding volume. So imagine if you're cloning inside this. So you're creating a grid clone, and you have clones on the X, on the Y, X on the Y and the Z. So let's assume that this is the U, this is the V, and this is the W coordinate. Every single clone that lies over here, they have a W coordinate of 0, and everything that's over here will have a W coordinate of 1. If the bounding volume was this big, again, there would be 0 and there would be 1. So it's a relative normalized parameter that tells you at which percentage of the X, Y, and Z of the bounding volume, a box that encompasses the whole set of clones, your clone lies. That has an exception. If you're using any cloner in object mode, then when you read an object like a sphere, for example, then the UV coordinates become the UV coordinates of the sphere. So that is the exception, and there's very good reason to do that because you can control things based on the UVW of the object. So I hope that replies. The other question by Demisart is, the following. How do we create a 3D parabola? And in this particular case, I've done a little cheat. I've replaced the ID by divided by count with the U. So depending on where each clone lies on the distance on the U parameter, it receives a different value, the sign. And then I created another one where I exchange it with V. So it's not W, it's V here. So I apologize for that. And I just put both of them on the effector, and this is the result. And it's just a normal formula. And there's another way to do this. You can actually, it's not this, it's not this, it's not, it's this, where I don't need to. I just multiply the previous ones together. So I'll get something similar again. So this would be another type of 3D parabola and so forth. But overall, you'll find that once you get your head around the U's, the V's, and what they do, they just return a number from 0 to 1, essentially, and tell you how much of this, if it's 0, it's 0, if it's 1, it's 100, how much of this is going to be applied to each and every one of the clones. So once you get your head around that, you will find that you can do some quite interesting stuff without even having to know too much about things. The syntax is the most important thing, the parentheses and all that. But yeah, you're going to figure that out. So what was I going to say? I was trying to say something here. Did you talk about the scale and the push apart, Jonas?
No, I actually didn't.
So here's one of the important things about the push apart. The push apart effector, and I'm gonna use this as an example. I'm gonna create a sphere that has a radius of 10, and I'm gonna put it in here, and I'm gonna take the cloner, create multi-instances, I don't really care, and make this 8. So they're overlapping, all right? So let's go and add a few of those, and a few of those, and a few of those. Now remember, the sphere has a radius of 10. So if I go to this and I apply a push apart of 10, basically you will see that we have overlaps. That's because we don't have enough iterations. If you push the iterations high enough, this is going to stabilize to the point where you're not going to have a single overlap. But as you can see, the consideration the push apart effector takes is the radius. And it's going to try, if you go to 1 iteration, it's just going to push them out, from, 10. If you go to 1 iteration, you will see that it just tries, no iterations, 1 iteration, it tries once to push them apart. But because it pushes them apart one by one, first this one, then that one, in some sort of order, then another one that was pushed away happened to collide with another one. So you need an extra iteration. And now they're coming closer and they're pushing against each other again. And every time you increase the iteration, you get a better solution at a certain degree. And that is a probability because depending on the number of clones, you may never reach a perfect solution. At a certain degree, you have no collisions whatsoever because everything has been sort of smoothed out. Now, what happens if we have some scaling? So let's go and add a random effector here and tell the random effector to not rotate, but scale these. And let's scale them uniformly and, scale them up, scale them up. And now we're getting overlaps again. Well, the reason is very simple. Because the push apart comes before the random, it's unaware of those scales. If the random happened before the push apart, so the push apart saw this, then within the push apart's abilities is to take the radius, and every time it calculates that extra iteration, it takes into account any scaling that has occurred. So if you put your scaling first and then do your push apart, you actually get adjusted pushing apart operations that take into account the scale. So here you won't have any collisions whatsoever. And generally, to increase something which is additional to the built-in effectors, on University we have the CV effectors. Just go and search for CV effectors, and it's a couple of effectors that allow you to cache your objects just like you will do with a MoGraph cache, but in an effector, so you can apply more effectors after that. So go watch the tutorials. I'm pretty sure you're going to find these very interesting. So this is the little secret of the push-apart effector, that it does take into consideration the scaling of the objects, providing it's applied after whatever scales we want to take into account. If we have multiple scaling going on, it's better to put the push-apart at the end, so it resolves everything based on the scale. Good. Let's see now. What else did I want to say here? Do I have anything interesting? We did the parabola. I've got an empty scene here. We did this. Oh, very quickly, and this is more about the formula, just to give you some little sneak peek on the fun we're going to have next time, that you can use a formula field in a selection tag on an editable object, and you can actually use that modulo. And I posted a link to a YouTube tutorial I have about moduli and what it is, which is basically 24 hours of a day on a 12-hour clock. That is modulo 12. So go figure out. In Europe, they use 24 hours. In the United States, they use modulo 12 hours. So the 13th hour is 12, 13 divided by 12, and that has a remainder of 1. So 1300 hours is 1 o'clock. So you have been using modulo for the best part of your lives. You just didn't know it. So here you can select every second polygon. I've applied a material to make them visible. I can select every 5th polygon. So it's amazing what you can do. You can apply all sorts of things using the modulo if you want to select every other. So that's the most functional thing. Every other, this number, you can create a selection and so forth. So that's as far as the modulo goes. I just want to show it in another context. So let's go and do this. This is very close to my heart because I couldn't figure it out. I was going bonkers until a while ago. Orestes Konstantinidis, a very good friend of mine, and he is responsible for a lot of nice things you see in Cinema 4D. He explained how to do this particular thing. So the problem I was trying to solve is that I have a Voronoi fracture that is defined, and I think I have this in X-ray or something like that. I don't want it X-ray. So I have this cylinder, and I have Voronoi fracture in which I've dragged my circle. And because the circle is creating these points, I get this nice radial pattern here, which I can move around based on the center of the circle. Nothing's going to happen if it goes closer or further away. Now, what I want to do, I want to move these using an effector, but I want them to move radially. So it wasn't an easy thing to do. So what you do, you tell them, let me get rid of this and all the distance and all that. So if I go, so let's go to the Voronoi fracture and let's apply the target effector, right? So the target effector in repel mode allows you to do something akin to a plane effector, but based on a distance and on all these sort of things. But because the target effector will rotate your clones to point to the object. Look at that. So it's pointing to the object. It's repelling them as well. But you can see that they're trying to point to that object here. So I need to find a way to, on the one hand, I want them to point in a certain direction so I can repel them. But at the same time, I don't want them to be rotated. So what you do, you go to the fracture object into the effectors here. And after the target effector that has applied, the target effector has applied a particular rotation, and with a repel, it's creating some motion. I want to remove that rotation. I don't want that rotation. So you go to the ReEffector, and basically the default ReEffector has everything on. So let me just go and apply a ReEffector to this. I can just remove it from here so you can see the whole thing. Go here, go apply a ReEffector. And now I want to tell this ReEffector that, you know something, I want you to just include the rotations of these things and not touch the positions. I want the positions to be controlled by this. So by using this combination, we're actually able to rotate them while not rotating them. And again, maybe the explanation needs to be more than a minute and a half, but you can see that the ReEffector can do much more than what it appears to do. I think it was originally designed to just remove certain of the parameters that are affected by the effectors, and consequently, you can use it in all sorts of different ways. So let me see if I have anything else interesting for you. Are there any questions I've missed around here? Let me take a quick read. You can set most effectors point. That's Sassy replying. I'm not going to read that. They're going to control the position. Can you use an effector to control a position along a spline as opposed to X, Y, or Z? Yeah, that's where the spline effector can be used, at least if I understand the question correctly.
The problem with the spline effector for what he's trying to accomplish is that, and let's see, I think that was Neil that asked this question, was that it distributes them uniformly on the spline, and he was wondering if there was a additional control there.
Okay. So I would do it using other ways. Let me put it that way. You can use what can you use? Maybe a spline wrap or something like that on the on the matrix. Again, connecting to the previous lesson we did. If you take a matrix and set your matrix to linear, I don't know if this is going to answer the question, but I'm going to say it because I think it's fun. So let's go create a couple of these buggers over here. Then I can take this matrix and apply a spline effector, and I can apply this and tell this that this is my spline. So now I'm assigning those there, and then maybe I can create some sort of text and apply. How can I do that if I want to do text? Yes, so I'm just going to create a text object, a MoText object, and type a Noseman or something else very interesting. Then take this, and again, I'm showing an overcomplicated way because that's how my brain works at this current moment. I'm going to use the connect object. Sorry, where's my? I'm in the wrong menu. That's why I can't write. The fracture that's going to take everything, and it's going to break it up into segments. And what am I going to do then? Actually, you don't need to do that. No, it's wrong what I'm trying to do. Oh my God, but maybe we can put a spline effector in this. I have no idea what I'm doing right now. I've lost my train of thought. I had something very, very, very specific in mind, and I don't remember what I was trying to do. Yeah, so forgive me. Oh my God, I totally, totally missed the point of what I'm doing. But since I'm here, and let's get rid of the major C's and just go to the text, and I'll show you how you do. You go to the letters, because so this is a MoGraph object, right? The text object is the old MoText. You have a spline effector in which we will apply our little circle just like before, or anything like that, right? Make sure you don't drop it in the rail. It won't really help. And then you tell the text that in the letters, I want the spline effector to go and affect them. And then it's up to you to go and do some fine tuning with the rotation here, and create your min and max positions, and where this is going to be. And basically, I eyeball it. I can never, ever, ever remember exactly where everything needs to be. So I'm going to start rotating these at 90 degrees or something like that, in order to get them to work. And yeah, well, why is it? Oh yeah, you need to get the circle, because circles are counterclockwise, and reverse it. There we go. So now what am I going to do? I'm going to go to my spline, and I'm going to move it and extend it over here. Oh, and it's the other way around. So let's do this, and let's do this. And there you go, Noseman. I made it. So minus 90.
Woohoo!
Minus 90. Yeah, I can do it. I can do it. And what else do I want to do? Anyway, pretty much this is how you would do it in the Spline Effector. And I really, really apologize for totally forgetting what I was going to say. But I'm getting old.
Well,
just
yeah, I think our audience is going to forgive you, but we all know that it's we are sure that it was genius.
All right, watch this now.
Right.
You would wonder, how do we place these letters now to sit right at the bottom, right? How do we do that? You go to the spline effector and there's no position thingy going on. Well, it's not a fault of the spline effector. The text object, the MoText, by default for each and every one of these components has this axes. And for anyone that didn't know, it's currently placed in the middle of the letter. That's why we get those green dots. You just drag this all the way down and you can control if it's going to be aligned at the top, at the bottom, and all sorts of other stuff. So then you just go around it and so forth. So now
Yeah,
you're
that's clever.
done.
That's actually something I ran into quite often. Yeah, so
that's
I
all
have.
I have for today. Yeah,
That's great.
this way.
I have two more things. I mean, we
Please.
are already overrunning by 5 minutes, but I want to show the time offset stuff because it's really, really interesting. So let me share my screen. And what I have here is an animation of these clones. So I have clones cloned in a grid. As you can see here, and if I press play, you can see that all of these clones are animated. They are doing this one jump that I animated. And now let's see what we can do here. So first of all, maybe we want these clones to loop their animation. And we can do that by going to cloner, and then under transform, we have these animation modes. And here we can set the animation to loop, and that would make everything loop. So now we have looping animation. Okay, great. But what does this have to do with the effectors? Well, until now, nothing. But there is another animation mode called fixed. And fixed will, if I hit play now, you can see that it is fixed to frame 0. And I can control the animation of these clones now by using this parameter. Right, still doesn't have anything to do with effectors, but let me show you this. So what we can do is we can add, let's say, a plane effector, and then instead of affecting the position, we want to affect the time offset. Cool. Now, let me bring this up a little bit, and you can see that the further I go up, the further this animation will be played back. Now, let me have a look at the timeline and have a look at the animation. So these are all of the keyframes, and the animation is 80 frames long. And that is important to know right now, because we have to type in that number here to get the full animation. So now we have everything restricted to frame 80. Right. How does that help us? Well, we can go to the Fields tab here. And now if we add a linear field and make it a little bit bigger, you can see, okay, now those guys are jumping. And we can animate this linear field to the left and to the right, for example. And now you can see that we can control the animation of all of these objects here by using this field, which is pretty cool. There are some other things you can do with that, but I would save that for next time, because then we're going to go into fields. But by using fields, you can, for example, just randomly make them jump, like randomly offset it. You can even adjust the speed of jumping. And as another example, you could also like create a more complicated animation. Let's have a look at this. So if I scrub the timeline here, you can see that we have this chair and it's building up like Transformer style. And here I can control all of this by using this linear field now. It's the same setup. And you can see that we can, animate like that. So
Jonas,
back in my days. Yeah, yeah.
Can you go back to your cube scene? Because it's a
Yes.
very good example of the general concept around effectors. So go and select those 80 frames you found in the timeline. Select your plane effector and go to the 80 frame value. So in your plane effectors
You mean here?
parameters, good. So the time offset is the maximum value, in this case of frames, the effector is going to apply to whatever it's connected to. So in this case, the cloner. Just like with every other parameter, position, scale, rotation, weight transform, and all that, you use the maximum value you want in whatever field you want. And if the effector is 100%, then the clones are going to receive the maximum, which is 80 frames. They're going to be at the 80th frame of their animation. Whereas if you go to your effector, get rid of the field and set the strength of the effector to 50%, that is going to go to the 40th frame in the effector, yeah. So because that is 50% times 80. So that's how you need to think of things. You set in the parameters of the effectors the maximum values you want to achieve when your effector is applying the effect 100%. And that applies for all the parameters you set. Once you get your head around that, suddenly you're going to have a cascade of understanding of how fields work, how effectors work, and all that kind of stuff.
Exactly. Yeah. But as we said, fields are the topic for the next one, which is for the next session in 2 weeks. Or is it in 2 weeks? And this is going to be very exciting because fields are just so amazing. They are actually one of my favorite parts inside of Cinema 4D. Right. So we are already 12 minutes over.
Aww.
So that's pretty much one Thanut. And yeah, let me show you like a few of the housekeeping things again. If you want to sign up for more of our free webinars, you can go to the events page on the Maxon website. You find that under news and events, and here we have all of the events, the webinars, and so on that we're doing listed. Then, if you like missed one of the sessions or like came in late, the Maxon Training Team YouTube channel is the place where you can watch the recording. Then, of course, those sessions at the moment are based on our certification tests. If you want to become a certified artist, then you can get all of the info here on that side, including the certification topics list. And this is the one that we are going through while finding out the potential topics for Ask the Trainer. You can always write us and ask for a specific topic that you want to see covered in depth. And then again, there is a link. It has been posted earlier, but maybe Sassi, Ellie, or Darren are going to post it again to our Maxon merch store. And here you can type in or paste in that coupon code that they're going to share as well. And then you get to this side and you can pick one t-shirt and order it for free. You will only have to pay for the shipping. And that's pretty much everything we have today. So thank you, Noseman. Thank you.
While I'm looking at Tsukamaki windings, that's interesting. There was a question. Can't be answered today, though.
Yeah, we'll do that next time.
I think there's a YouTube video out there.
Yeah. Also, thank you, Darren. Thank you, Sassi. Thank you, Ellie, for taking care of the chat. Also, Michelle was taking care of the chat. And also Hashi, who is producing the scene, the show in the background. So thank you, and see you next time, everyone.
Bye, everybody.
Bye.
You had a terrible choice to make in Berlin. One life over millions.